Summer Physics 3-4, we're on to our next lesson, and this is going to be on the subject that's related to electricity, and it's called magnetism. So how are magnets oriented? In natural iron, the atoms are pointed in random directions. When the iron is placed under a magnetic field, the atoms line up in a north-south orientation. So just as we say electrical charge has a positive and a negative, the negative are electrons, the positive are protons, then magnets similarly have something similar to that called north and south poles. So when a magnet is broken in two, the atoms in each new magnet have the same north-south orientation. So what does a magnetic field look like? Well, the North Pole is attracted to the South Pole of another magnet. So we'll play with some magnets today. They stick together. And if you turn them around, if you orient north to north, they'll repel each other. They'll push apart. Similarly, south to south will repel each other. So in addition, a magnet's North Pole is attracted to its own South Pole. This means that the magnetic field comes out of the North Pole and wraps around the magnet and comes back to the South Pole. So you see a magnet there. On the left is just an illustration, but on the right is actually a photograph, and those are iron filings, and they form almost that kind of spider web looking shape. So the North Pole is pointing towards the South Pole. As it comes out of the right side of the North Pole, so if you look at the magnet over on the right, if it's coming out of the right side of that North Pole, in other words, way off to the right, it will loop and curve way up and around and back to the South Pole, or it'll curve way down and around and back to the South Pole. So that is the direction of the magnetic field. So why is that important? It's important because that magnetic field can push other magnets, and that can cause things to move. So how does current create a magnetic field? So when electrons are in motion, they will create a magnetic field. So all electrons produce an electric field, but when the electrons are in motion, they also produce a magnetic field. When current moves in a straight line, such as through a wire, the magnetic field circles the wire. If you point the thumb of your right hand in the direction of the current, then the magnetic field will be in the direction of your other four fingers, and this is called the right hand rule. So you can see the illustration of the right hand, and the thumb is pointed to the right. So that means the magnetic field is going to wrap around as though it's coming up from behind, over the top, and out of the screen towards you. That's what that illustration is showing right there. So how can a magnet create an electric current? When a magnet is moved through a wire coil, it induces, the word induce simply means to cause, an electric current to flow in the wire. In the diagram below, I is the electric current and B is the direction of the magnet's movement. So if that magnet is moving from left to right, it will cause a current to flow down and around those loops and then down out the bottom there. A device that changes the motion of a magnet into electric energy is called a generator. So how can a magnet create an electric current? The amount of voltage and current in the wire coil depends on two factors: how many loops the coil has in it and how fast the magnet is moving through it. And this is known as Faraday's law. What is a transformer? So when two coils are wrapped around an iron core, that gray thing is called an iron core. It's made out of iron. It makes the magnetic field stronger and therefore changes the amount of voltage and current in the right side of the coil. So this device is called a transformer. A transformer does not create power. It trades voltage for current. You can't create power just by having a piece of metal. But if you remember, the formula for power is power equals voltage times current. So you can have the same amount of power and increase the voltage by decreasing the current, or you can increase the current by decreasing the voltage. You'll have the same amount of power in both cases, but you'll have either more voltage or less voltage, more current or more current, depending on what your needs are. So that's what a transformer does. What is direct and alternating current? So the current we've talked about in this class so far is direct current because it moves in one direction around the circuit. Alternating current moves in a back and forth motion. This is the best way to transmit electricity over large distances because electrons move a short distance back and forth, back and forth, back and forth, rather than many miles through power lines, which is really inefficient. So current comes out of the wall as AC at 120 volts. So it's just, again, those electrons are just moving back and forth. You can transfer the energy into an electric fan or into the San Diego trolley or a washing machine by doing that rather than having the electrons just moving in one direction. So current comes out of the wall at AC, alternating current, at 120 volts and 60 hertz. That means it moves back and forth 60 times and every second. But it's converted to DC by the electric fans or the washing machines or whatever you're using. So they have a way to convert that into a direct current. Okay, and that takes care of this lesson on magnetism.